We call this type of function a rational function. So if you're trying to find the domain and the range, you want to consider values for, so let's just start with the domain. The domain is asking you what values can you put into the function. So what, in this case, what values can you put in for x? There's only one value that we should exclude, and it would be the value that make the denominator equal 0. So we just want to set up a quick little equation off to the side, solve that equation, and you should get x is 1/5. We can't have x equals 1/5 or else we'll have a divide by 0 error. So in interval notation, you can have all the way back to negative infinity. Keep going to the right on the number line until you stop at 1/5. Put a parentheses, and then we need a union because then we can join it with another interval. You can start at infinitely close to 1/5, but to the right, and go to positive infinity. The range is all the values that come out of a function, so all the y values is one way we usually think of it. So with a rational function, that's sometimes tougher to do, especially if it gets complicated. Sometimes using a graphing calculator to check yourself is a good idea. But let's see. I think one good thing to consider with the range is to think about any sort of horizontal asymptotes that occur. Okay, and I'm talking about horizontal asymptotes, not vertical asymptotes, because if a horizontal asymptote occurs in a rational function like this, we get infinitely close to this number like 2, but we never quite reach it, right? So we'd have to exclude 2 from the range. So when you think about horizontal asymptotes, there's a set of rules to check. It's just 3 statements to check. Think about the highest power in the numerator and the highest power in the denominator. If the highest power is in the numerator, if the power in the numerator is bigger than the highest power in the denominator, there's no horizontal asymptote. If the powers match, then the end behavior of the model is going to be a ratio of the coefficients that's going to get closer and closer to 7/5. And that's what we have here. They both have x to the power of 1. So we're never going to reach 7/5. We can go all the way back to negative infinity. But when you get to 7/5, same thing. We have to exclude that value. And if you're not sure if you really should be excluding 7/5 or not, remember you're talking about y values. So plug 7/5 in here. Try to solve that equation. Yeah, I can do it real quick. Oh, no, I can't. That'll take a while. No, so that's 7 minus, okay, 7x minus 7 equals, yeah, you're going to get something that it's going to be like negative 7 equals 5, which doesn't make any sense, right? So that means 7/5 can't happen. So there's your range and interval notation. And just a quick note, when I was typing this in, I realized some students might not know how to use Newton at this point in the course. You want to click this arrow to get different symbols. We want set notation to get that union operator. You can go back to the basic symbols if you want, but then we said for the range 7/5 to positive infinity, close that parentheses. I forgot what my domain was. Okay, 1/5 was the exclude value, so negative infinity, 1/5. Don't worry if you get it wrong, right? Because Newton lets you retry things a bunch of times. Oops. Okay.